Okay, so we're starting a new chapter today on percents. We're going to look at understanding our concept of percent. We're going to see that we can use percents to compare quantities and for proportional reasoning. We're going to focus on looking at very large percents, so percents over 100, and very small percents, so percents under 1%. Before we start, let's look at some examples in everyday life where we would use percentages. So I want you to brainstorm as well as I'm writing some of these down. Think of where you would use percentages in your day-to-day life. And some things that I came up with were sales taxes. So we have 5% GST and 7% PST when we go shopping. Okay, and when we go shopping, hopefully we encounter lots of discounts. So you may be wanting to buy a pair of jeans that are 30% off. If you ever look closely at the food you eat, nutritional labels also contain percentages. I looked at a carton of milk and I noticed that vitamin D is listed at 45%. Of the percentage daily value. Okay, so when you drink 1 cup of milk, you get 45% of your vitamin D. Another place where we would encounter percentages is in statistics. This is a big one. We see statistics everywhere in sports, in finance, in health. So, for example, with COVID-19 right now, I was just looking at the Canadian website and it said that 23% of all COVID cases were either exposed while traveling or exposed to a traveler coming to Canada. So 23% of COVID cases were exposed through traveling or coming in contact with someone who had traveled. Okay, so those are some examples in everyday life. Let's move on to what percent actually means. And those of you that are well versed in French will notice that it is per cent, so out of 100. And we can look at percent in terms of a fraction as well, where we would compare the part to the whole. Okay, and we're going to be using lots of these hundreds grids here. And you can represent a percent by shading a 100 grid. So if we look at it in terms of shading a grid, percent shaded would mean the part of the grid that's shaded divided by one whole grid. Okay, so in this example here, I'm going to look at 64 squares. I'm going to shade 64 squares out of 100 squares. You can use a highlighter or a pen, pencil crayon to do that to make it more exciting. So I'm going to shade 64. So we'll just do 10, 20, 30, 40, 50, 60, and then 60, 64. So we say that we have shaded 64% of the squares. Okay, Next, we're going to look at, I thought this would be an interesting little activity that we could have done in class. We'll do it here through our notes. What percent do you make up of all the people in your family? Okay, so we're going to use that part to whole to go through these. So in my family, for example, I am 1 part of 5 wholes. So 1 divided by 5, I want to turn that into a percentage. So in my calculator, I would go 1 divided by 5, which equals 0.2. And then I would times it by 100 to get my percentage of 20%. So I make up 20% of my family. You could have also set up a proportion to the bottom, which would have been 100, and you multiplied it by 20. You multiplied the top by 20 as well to get 20%. Moving on into our classroom. So our classroom's a little bit bigger. Let's just say we have 30 students. So I make up 1 part of 30. Okay, so 1 divided by 30 in my calculator is 0.033333 repeated. So I just put a little bar on top to show that. I want to turn that decimal into a percent, so I multiply it by 100 and I get 3.3% repeated. So it's a little bit smaller. Notice this percent includes a decimal portion or a fractional portion. We'll be talking about those a little bit later. Okay, let's move on to the school. Let's say we have a school of 1,500. That's about the size of Fraser Heights. So I make up 1 of 1,500 people in this school. I plug that into my calculator. It's going to be a small number here. So 0.0006 repeated, and to turn that into a percent, I multiply it by 100, and I have 0.06%. So I make 0.06% of Fraser Heights, and we could keep going. Notice they're getting smaller. This is a very small percent. It's less than 1. Let's just do British Columbia as well. So in 2016, our population was 4.7 million. So I would have been, so in 2016, using data from then, we had a population of 4.7 million. So I make up 1 part to 4.7 million. So I have to write that out the long way there. Plug that into my calculator. I get a very, very small 6 zeros and then 213. And then to turn that into a percentage, same thing, multiply it by 100. So 0.000021% of British Columbia. Okay, so we notice we're making up a smaller and smaller percentage as we're getting into a bigger and bigger population. The classroom, the school, and British Columbia all have decimals in their percentages. Those are called fractional percentages. And in the school and in British Columbia, our percentages are less than 1. So those are examples of small percents. Okay, so let's move on to the second page. So a big concept here is percents can be very large or very small. So let's look at some examples of very large percentages. You could have gotten over 100% on your math test. A population might be 110% of its value last year. You sell your house. For 130% of what you originally paid for it. Okay, and let's look at some small percentages. So we'll do those in a different color here. Operators in a factory might find that 0.5% of products are defective. In a manufacturing plant, for example. And another example here, I've got a picture to the right, is the atmosphere. So let's take a look at the gases, the composition of the atmosphere. It's a mixture of different gases that surround the Earth. You'll notice nitrogen is 78%, oxygen is about 21%, and then we get into some really small numbers. So argon makes up 0.93%. So argon is an example, makes up so less than 1% of the atmosphere. And then we have some other gases as well, xenon, neon, hydrogen, helium, etc. So some examples of some very large, some very small percentages. So some key terms to move on, to know before we move on. Percents that are greater than 100% occur when the part, so the top number, is bigger than the whole that it's being compared to. So this picture here on the left, the shaded part is more than one whole grid. So we could write this as, this is 100, and here this is 70. So this is an example of 170%. So once again, the shaded part is more than one whole grid. Okay, a very, very important term, fractional percents. They occur between 1% and 100%, and basically they have a whole number and a fractional or decimal part. So let's take a look here at this example. So here, if I was to count it, I have 25 squares that are shaded. And to the right here, I've taken one square and I have magnified it. And let me count them up here. So I have 4 of the 10 shaded. So I have plus 4 over 10. So basically, the shaded part has a whole number of squares and a portion of one square. That's an example of a fractional percent. And if I was to write that out, I would write that out as 25 and 4/10 of a percent, or I could divide that. So 4 divided by 10 is 0.4, and I could write it out as 25.4%. Okay, and then lastly here, percents that are less than 1%, those happen when the part is significantly less than what it is being compared with. So the shaded part here, I've got one square that's been magnified, and you'll notice that one quarter of it has been shaded. So that means it would be 1/4%, or we could turn that into a decimal. So it would be 0.2525%. Okay, and one thing I wanted to say, I'd like you to highlight this. Percents that are less than 1% are always fractional percents. So percents less than 1 are always fractional percents. Okay, so on the third page now, let's get into some representing percentages on grids. So the first one is 7.4%. So this is a fractional percent between 1 and 100. So we would shade 7. And then we need to represent 0.4. So we take that 8th box and make it larger. So how do we represent 0.4? 0.4 is the same thing as 4 over 10, which means we would break this up into 10 portions and shade in 4 of them. So that's 7.4%. You can pause the video and try these on your own and then check your answers as well. Question B, we have 1/6 of a percent. So this is a fractional percent that is less than 1. So we would take, we would zoom in on one square here, and we need to break it up into 6 parts. And we shade in 1/6 of it. Okay. In question C, 34 3/4 of a percent. This is a fractional percent as well, where we need to shade in 34 squares on the grid. So 10, 20, 30, 34, and on one grid on one square we need to zoom in and show 3/4. So we would split it up into 4 sections and shade in 3/4 of it. Okay, question D as well is also a fractional percent because it contains a decimal. So we shade in 2 whole squares to represent the 2%, and now we need to represent the 0.3%. So we take this square, zoom in on it, and we need to represent 0.3, which is 3 over 10. Okay, so we'll break that up into 10 sections and shade in 3. Okay, last example, representing percents visually using hundreds grids. So 1 serving of orange juice contains 135% of the recommended daily intake of vitamin C. So since 135 is greater than 100, we need more than 1 grid. So we would shade in 1 whole grid. And on the second grid, we would shade in 35 squares. Okay, second example, in a document called the United Nations Millennium Project, rich countries have agreed to try and contribute 0.7% of their yearly gross domestic product. So that's the total value of goods and services produced to help developing countries. So this is an example of a fractional percent less than 1. So once again, we zoom in on 1 square, and 0.7% is the same thing as 7/10 of a percent. So to show that, we would break up this square into 10 parts and shade in 7. Okay, and last example, a credit card company charges an interest rate of 18.75% of unpaid balances. So this is a fractional percent between 1 and 100. So we use a single hundreds grid. We shade in 18. Oops. And then we zoom in on one square and shade in 3/4 of it, or 0.75, to represent the 3/4%. And there you go.